All right. Hello, everyone. Good morning. Welcome to the February 10th APAC community call. So in today's call, we have three agenda items here. So first, we would like to share some really good news from OHDSI APAC, and then we'll go to the Phenotype February that is actually ongoing as of now. And last but not least, we'll do a quick preview of what's going to happen in our next community call on February 24th. So the first one is really good news that we have our first ever OHDSI APAC study on the legend hypertension that has been officially published on JAMA Network Open. So here we really want to see a big congratulations to the whole OHDSI APAC community. Thank you so much for all of the collaboration, and we wouldn't be able to do this without that. And here I really want to give all of the thanks and appreciation to kind of all of the participant data partners or collaborators as well, which are the Yale University, IQVIA, and we have Kyunghee University Medical Center, Jeju University Medical Center from Korea, and we have two University of South Korea and University of South Wales from Australia. We have Jiangsu People's Hospital here in China, and also National University of Singapore Hospital in Singapore, and Taipei Medical University from Taiwan, and also UT Health from the US. So a big thank you to all of you, and again, congratulations.
Just let's make one correction. It hasn't been published. It's been accepted. I should say.
Well, be in yeah.
It's been accepted, and it will be published soon. But you know, it's great to see, actually, you know, all the hard work that this community has put into this first ever study. And if you guys were here with us during this journey since 2020, right, it really started off somewhat rough because a lot of our databases and a lot of our partners didn't have all the tools or even their database or experience running a network study. So we ran into delays, we ran into issues, but as a community in the Asia Pacific side, we worked it through. And, you know, we've had a few posters talking about it, and then we got a lot more collaboration. And it's the first ever where you have five of the 6 countries in the APAC chapter actually participate in a study. So big round of applause for all the folks who worked on this particular study. And thank you for, like Jing said, for all the efforts. You endured it for a whole year with us, right? A year and a little bit, right? But it is extremely exciting to see this. And we're hoping with, you know, this as proof that it can be done, the 4 other ones that we're working on this year is going to go out, and hopefully faster this time.
Cool. Thank you, Mui. So that is just really some good news we have. And then, so next part, we are actually, we're gonna go to Phenotype February. So as you may already know, so that has been announced about a week ago in a global community call by Patrick. And here I have, you know, the link that you can actually go to. So there is actually daily update. So basically we're, I really like the rhyme here. So we have Phenotype February. So basically where the community will be working on 1 phenotype per day. And then the next will be playing kind of really the more detailed introduction, and also kind of really the background and rationale why we're rolling out this, why we're spending so much time and effort as a community, that we want to not only standardize the CDM and vocabulary, but we want also to have a collaboration that we could have a standardized version of the phenotypes for the most common or the most interested disease out there. So with that, I will start playing the video from Patrick. All right. Let me know if you can.
Phenotype February. This is going to be an exciting month for our community, or at least I hope it will. What I'd like to do today is really kick off this month by describing an idea that I have for our community that I hope you all will join in the fun and learn a lot and actually deliver a lot this month to kind of catapult our community forward. Most of you know that I have a really horrible work-life balance, and so I end up mixing stuff with my 6-year-old daughter with the work that I do while sitting here in my basement. And so sometimes I get confused when she's watching her various movies. And several years ago, I hear these songs and I would hear things like, do you want to build a phenotype? But that is very played at this point because that's very old. And we're now on to, we don't talk about measurement error, no, but we need to, because this is a fundamental problem that we have, no matter what your cultural affinity may be. Today I'm going to talk about all the opportunities for us to develop phenotypes as a community. But first, I need you all to help me by providing some input about what phenotypes we actually should build in Phenotype February. So, Craig, if you wouldn't mind just pasting the link in the chat, if you guys can go to pollev.com/PatrickRyan800, you're going to see that I've started a community discussion specifically asking the question, what phenotypes would you like to develop and evaluate together? And you're going to actually see that there is actually a lot of phenotypes already offered as suggestions for us to consider. To provide a little bit of context, I took 100 product labels from the US FDA's website, and for those I extracted out all of the indications for those product labels, as well as every adverse event or every adverse reaction that was listed on those product labels. And I just compiled a list. And that list is about 160 some odd outcomes long. And we could think about that as like, if there's 100 marketed products in the US that are actively used across a range of different therapeutic areas and whatnot, and there's lots of adverse events that are being reported as potential causal effects of those treatments, then surely we should have good phenotypes to enable our use of our observational data to study those effects of those products. And yet, as you are scrolling through that list and upvoting the ones that you like, you're probably going to be thinking, geez, I really haven't seen very good high quality observational research on all of those outcomes. I'm seeing Thamir nodding, he's thinking like, geez, yeah, I've got to regulate tons of this stuff, and most of this stuff has like no really good, well-defined definitions in the literature. And this is really the fundamental problem that we have. We do research where we are predicated on having really high quality phenotypes, and yet the list in the universe of phenotypes we'd like to have, we're still as a community kind of waiting for high quality definitions to be developed and evaluated. So I want you, as I'm talking, you can multitask and look through that list. I'd like for you to find some phenotypes you like and upvote them. If you see phenotypes that are missing that you really think we should work on, feel free to add them to the list. But I'm going to be coming back to that a couple times throughout the rest of the 40 minutes to see where we're at and where we want to prioritize and focus during our community month of Phenotype February. So many of you have seen this canonical picture. It's in our book of OHDSI. It talks about our journey from data to evidence usually starts with raw data converted into the OMOP common data model. And then we generically talk about that we apply code to the CDM, and that code generates evidence that we make open and accessible. And of course, this is the mantra of how we work as a distributed data network, and we've been successful in this approach. I want to dig down just one step further to talk about the importance of this general process, because we can think about the fact that we have standardized data, and we can think about the opportunity of standardizing analytics to generate impactful results. And we actually have lots of demonstrated successes with this. We've developed standardized analytics for treatment pathways, and George published a paper in PNAS several years ago that highlighted the value of looking across a network for treatment pathways. We have developed standardized analytics to characterize incidence rates, and we've showcased the work by Jingtong Li that was published in BMJ to support the COVID-19 vaccines by computing background rates of adverse events. And so these are characterization use cases that we've had some success with. We've seen the use of comparative cohort designs as a population level effect estimation tool, and we've had impactful results, including Mark Suchard's paper in Lancet, where we showed the legend results for hypertension. We also have other population level effect estimation tools like self-controlled case series, and probably seen the work that Jenny Lane and Janie Weaver published in Lancet Rheumatology, where we highlighted the risk of hydroxychloroquine that was supported in some of the early decision making during the pandemic. And so those are examples of population level estimation tools. We also have our patient prediction. You just heard just earlier Ross Williams in the successful work of the cover model that was established and just published this week. All of these very diverse, impactful results of different types of analytic use cases, they actually have something in common, something actually profoundly important in common that is totally underappreciated and underrepresented, and that's cohort definitions. Cohort definition is a specification to identify a set of persons who satisfy one or more criteria for a duration of time. And for each of these standardized analytics, the input to those procedures are cohorts. Whether that be a treatment pathway study where we have to define a target population and a set of events, whether that be an incidence rate analysis where we have to define a target population and the outcome of interest, whether it be a comparative design where we have to define a target, a comparator, and an outcome, a self-controlled design where we have to define a target and an outcome, or a prediction where we have to define a target outcome, the input that is required to do all of these important analyses that generate impactful results starts with having high quality cohort definitions. And yet, as a community, we sometimes have a recognition that this is an important problem, but we don't, I would just submit, we don't actually put nearly as much time and effort and emphasis really enable the entire enterprise of what we're doing together. At the start of the year, you heard me talk about that one of the things I'd like to see us do is think about how we can take a more systematic approach to evidence generation and to build a system for producing evidence that can actually scale. But at the very, very, very top of this picture, the first required input of such a system would be that we have phenotypes. And so if anybody is actually interested in my motivating or my motivation of building a system, then please help with building phenotypes, because we can't use a system if it doesn't have its inputs. That's like buying a car but not allowing you to have fuel to actually run the engine, or battery, as the case may be. But phenotypes are an essential required input to this overall process. And so we need to actually put the same amount of rigor and energy and attention into that activity as we do all of our other analytic activities. So briefly, for those that are new, I'm going to try to be precise in the language that I use to describe things today. We have tried to define a cohort in OHDSI as a set of persons who satisfy one or more inclusion criteria for a duration of time. We have the notion of a cohort era, which is a continuous period during which a person has satisfied a cohort's inclusion criteria. In the OMOP Common Data Model, we have a table called cohort, and it basically represents the identifier of a cohort, the subjects that belong to the cohort, and the duration of time represented by a cohort start and cohort end date. So in this one table, you could have multiple cohorts. Those are the different IDs. You could have multiple records. Those are the cohort eras. And then, of course, you've got individuals who satisfy these durations of time. There's some consequences to this definition that we've been trying to consistently apply across our analysis. One cohort could have 0 or more eras. And so that's based on cohort definition and whether or not there actually are people in the patient level data that satisfy those criteria. One person can belong to multiple cohorts. It's totally reasonable that a person could belong to a diabetes cohort and a hypertension cohort. And in fact, we would expect substantial overlap there. One person can belong to the same cohort multiple times, and this is particularly important and should be considered as we think about recurrent events, whereby someone could have a disease, the disease could go away, and then it could relapse sometime later. But one person cannot belong to the same cohort multiple times during the same period of time. Effectively, what we are modeling through the standard representation and through our standard definition is this idea that a given person belongs to the state of being in a phenotype or not at any given moment in time. And that's what we're modeling in this standard representation. Now, a cohort definition is basically the specification to populate this table. And when we talk about all of our standardized analytics in OHDSI, we start with a populated version of this table being the input to then enable all of our analysis. So the types of questions we oftentimes have to ask when we are thinking about designing a cohort definition is, what are the events that we need to observe to let a person enter a cohort? What inclusion criteria do we want to apply to those events to determine whether or not that is a qualifying event? For each of those events, like how do you actually satisfy, how long do you satisfy the inclusion criteria, or what is the end date that would have you leave a cohort? And how do we actually combine those events into logical cohort eras? For those that are newcomers to the community, we've got various tutorials, including an entire course on cohort development and phenotype building that's available on the Eden Academy that I encourage you to take a look at. And we've offered tutorials over the last several years that are recorded and available on the OHDSI website. But despite the fact that we've been offering these tutorials for years, we've got various tools that are available still within our community. We do not have a fully populated, signed off, and agreed on library of phenotypes that we can all take advantage of and reuse for all of our research. Instead, pretty much all of you who are starting a new research study start by saying, what phenotypes do I need? And geez, I guess I got to go build those things. And also not always taking advantage of shared best practices that have been learned by the community and can be learning from the prior tools that actually have been built and phenotypes that have been already shown to be effective in various places in our community. Inside of our cohort definitions, we very often use concept sets. Concept sets are an expression that basically represents the list of concepts from the OHDSI vocabulary that we want to use to identify events. Depending on how one goes about implementing a cohort definition, these concepts and expressions can be very useful tools, and we've actually focused on quite a lot of our standardized studies have been focused on developing concept sets that we can actually reuse in some of our studies. And we represent these in ways that are both human readable and computer executable. Just as a way to think about a phenotype development and evaluation workflow using tools. So I hope that you guys can hear me. You just lost 30 seconds? Okay. That's all right. I'll just speak twice as fast in hoping that you get half the words and kind of can make sense of it. Concept set expressions, we've developed a series of tools in our community to enable building concept set expressions, so that can be fun. We have developed standardized tools to enable writing cohort definition logic, both through graphical user interfaces as well through R programming. And so this basically involves answering those questions. What are your initial events? What are your inclusion criteria? What is your exit strategy? And then we've also developed, and this can be an iterative process. Once you develop a cohort and execute it in a data set, you can go back and think about how you have to reevaluate or reassess your concept set expressions. We've also in our community developed tools to evaluate cohort definitions. And so we have various tools to support this. An example is cohort diagnostics, which I'll show, whereby we can actually generate aggregate summary statistics from our network of databases and evaluate whether a cohort definition makes sense and is appropriate for a different study that we're going to have. And similarly, this can be an iterative process, that what we learn from the data can help us to refine our cohort definition, or what we learn from the data could actually help us go all the way back and actually revise our concept sets. And so as we think about a workflow for developing and evaluating phenotypes, we can think about trying to advance the science of phenotyping to involve a disciplined, systematic process that we can follow that provides us some sort of empirical evidence that definitions and phenotypes we've created are reliable to be used for any of the analytics that we actually want to answer. So for those of you who are unfamiliar, we have a large collection of really cool OHDSI open source community tools that support activities in the phenotype development process, been built by an awful lot of members of our community. I'm just going to highlight 6 of them here, just to show you how all the pieces can kind of fit together towards this bigger picture puzzle. Many of you are familiar with Atlas. This is a graphical user interface tool that we use to design studies. And there are a couple components inside there that can be actually quite useful for phenotype development. The cohort definition feature inside of Atlas is where one can go through the activity of pointing and clicking through designing a rule-based cohort definition. There's also other functions within Atlas that can be useful. I'll just highlight, because it's not often used by many people, is the profiles tool, whereby once you have a cohort, which is a set of persons who satisfy an inclusion criteria for duration of time, you can actually identify a given individual and examine that person's patient level data to decide whether or not you want them to belong to a cohort. Now, Atlas is a graphical user interface tool, so it's a web app that you can use. But Lee Evans and Martin have actually developed an R package called CapR, which is a really great new addition to our OHDSI library. And basically, this allows you to write R programming code to create the same cohort specification that you would through the user interface in Atlas. And this is a really exciting new tool to our toolbox, because sometimes you want to actually produce a fully reproducible process, or maybe iterate through programmatically to create a set of phenotypes. And this creates a language that can make that possible. So this is an important and useful contribution that I encourage you to check out. Anna has developed a tool in our community called Phoebe. This is a recommender system, so that when you're building concept set expressions, you can actually take concepts that you think might represent an idea and see whether or not other concepts might be suggested based on lexical matching and using the vocabulary hierarchy and other knowledge base that's come from our community. And I can tell you that, like, I can't successfully create
对，就感觉水面。
I do now.
你听，你看它就在放，然后它这个
approach to phenotypes. The basic idea is you can train a prediction model based on noisy labels, and then you'd have some sort of sense of the likelihood that a person belongs to the target phenotype of interest. Gautam has been leading a lot of efforts over the last year to mature the cohort diagnostics tool, and now there's been several contributors across our community to this. Basically, cohort diagnostics is a tool to evaluate phenotype algorithms using population level characterization analyses that allow us to be able to identify sensitivity or specificity or index date misclassification. And Joel Swerdell has developed a tool called Phebruary, and this is a tool that allows you to, given a set of phenotypes, one can actually produce an estimate of the sensitivity, specificity, and positive predictive value by training a prediction model and creating a probabilistic reference standard. And so all of these are examples of tools in our community. There are others, and I know other people are trying to mature new ideas. But the point is that phenotyping isn't just something that you should be able to think that you're going to be able to, like, do your own by open up a blank R console or SQL or whatever your favorite programming language is, just start hacking code. There's a lot of science and rigor to developing and evaluating a phenotype, and I think there's a lot of great opportunities to exploit these types of tools that have been developed in our community to make this happen. I see in the chat this question of how do you evaluate a concept set? So a concept set by itself is a list of concepts. One of the common things that happens when someone is trying to construct a list of concepts is they might start with some idea. I'm going to showcase in just a couple of minutes just the simple idea of type 2 diabetes. And so you might start with a string, a word like diabetes mellitus as something that you want to start with. But it is possible that if all you do is search for strings, that you might miss concepts that are highly related or directly synonymous with the clinical ideas you want. And Phebruary as an example of a tool is providing recommendations based on existing knowledge. And that evaluation that you can do is you can actually see what items you have missed, and you can think about whether or not those are actually applicable for your clinical idea of interest. And in my context, it is very often, I'd say pretty much almost always, I make a mistake when I start by creating an initial concept set. And Phenotype kind of saves my ass by finding the things that I missed and helping me be able to broaden my concept set to represent the ideas that I actually really need. Okay, so given that our community has lots of these tools that we've talked about phenotyping for years now, why don't we actually have together as a community already built phenotypes for all of those phenotypes that you are now all voting on right now? Well, that's really what has motivated my desire for coming up with this silly cutesy term Phenotype February. I would argue at this point, it isn't about the science of how to do phenotyping. It's not about having people's interest. I think it's about just we as a community just need to commit to recognizing the value and importance of phenotype and just spend some time on it so that we can actually make progress to socialize all of these tools, raise awareness of the scientific problems within the phenotype development and evaluation process, and actually just build solutions that people can take advantage of and reuse. And so my goal for us as a community, starting today, is that every day in February of 2022, we are going to have a new phenotype that's going to be developed and evaluated following OHDSI's current best practices. And so the daily task is going to be given a phenotype target, which is some clinical idea of interest. We want to create a clinical description. We want to review the prior work. We want to develop a cohort definition using OHDSI tools. We want to evaluate that definition using OHDSI tools. And we want to write a summary of the finding. Now, very, very often this process is something that I've watched and participated in where this can take months, maybe dragging on years to actually get done. Some of that is necessary and justified. I am not expecting that what we're going to end at the end of each calendar day in Phenotype February is going to be necessarily the final definitive solution to anybody's problem. But I would actually assert that at this point, given all the tremendous progress we've made as a community, given all that we've learned about the process, and given our ability to collaborate together, that it should be possible for us to make tremendous progress towards developing phenotypes that we want to use, to learn about how well they actually work across our data network, and to take advantage of shared focused effort this month to really try to accelerate where our current state is to where we actually want to be. So today, I'm going to start with type 2 diabetes, mainly because I know several of you on this call aren't fully socialized or aware of all of the OHDSI tools and how we could actually go about this process. So I'm going to kind of start a little bit slow with something that we should have a shared common understanding of clinically what this is. I'm also picking type 2 diabetes because Mark Suchard is leading our community through the development of our Legend type 2 diabetes study, which is going to be one of the most important studies we do as a community. And in the Legend type 2 diabetes, we already have a definition of diabetes we are using in our study, and it gives us an opportunity to raise awareness about what that definition is, how well it works, and why we feel comfortable in using them. But you can see that that's day 1 of 28 days. That means we're going to have 27 other opportunities to think about different clinical ideas and go after different phenotypes throughout the month. So specifically, before I go back to that chat to see how well you are voting on things, I want to talk about, like, concretely, what does this actually mean? So how can you all get involved in Phenotype February? Well, first and foremost, I just hope that you will join in a conversation. Every day we are going to post a discussion thread out on the OHDSI forums at forums.ohdsi.org. You're going to see a new thread. So later today, I'm going to post a thread called Phenotype February Day 1, Type 2 Diabetes Mellitus. And I am going to post my initial reactions to what I've learned from developing definitions and evaluating them across a collection of databases. That is to start a conversation, not to say this is the definitive answer, but rather to say, let's talk about type 2 diabetes and what we've learned so far. I really encourage you all to explore those definitions, to review the results that we're going to make publicly available, and to reply to the discussion thread. So add your own thoughts, add your reflections, whatever insights, whatever questions you might have. Let's have a conversation about type 2 diabetes on the forums so that we can learn from each other. Second way you can contribute, if you are somebody who has access to patient-level data in the Common Data Model, let's evaluate the definitions in your data. This is actually going to be relatively straightforward to do. If you have a CDM already in place, Things like Cohort Diagnostics is a standardized package, which means you can download the Cohort Diagnostics tool. There's actually an OHDSI study package that will contain within it the cohort definitions for Phenotype February. You can execute that package against your data, and you can review the results and share what you've learned from your own data. And you can even take it a step further if you're interested. If you want to share your results so that we can compile them across the network, we'll be posting all the results we receive on data.ohdsi.org. What we'll be sharing you today is a collection of different databases that I had access to, but it would be great to see more results from more databases if anybody's so inclined to join the journey here. And if you're really, really ambitious, well, we got 28 days. That means we got to do 28 phenotypes. That's a lot of opportunities to lead. I'm going to try to set a good example, or at least an example, and you can decide whether it's good or bad. But I'm going to try to set an example by taking the first week of Phenotype February and leading the discussion by having 7 different phenotypes on 7 different days, where I'll talk about my learnings from the phenotype evaluation process. But if anybody is so moved by looking at those examples and thinks, hey, that doesn't seem so hard, I'd like to do it, just reach out to me. You can send me an email at ryan@ohdsi.org, ping me on the OHDSI Teams environment, basically tell me what phenotype would you like to do and what day would you like to do it, and we can put you on the calendar. Ultimately, our calendar right now has got day 1 accounted for. This week, I'm going to take responsibility for these first 7 days, but it's kind of up to us as a community to make Phenotype February a success by having every day have a phenotype that we can learn about and discover together. So, one more item. We've created a series of Phenotype February resources that we're going to take advantage of. I want to thank Gautam Rao for setting up a lot of this over the last couple of days to get us ready for this, and to Lee Evans for making sure our shared community resource is all available. We have an Atlas instance that we are using for the OHDSI Phenotype Workgroup. And this is going to be the place where we're just going to stash these Phenotype February definitions. It's out at atlas.phenotype.ohdsi.org. This is something that if you want to be able to, it's security enabled. So if you want to get access to it, we have a forms, and I think Gautam's going to paste the link in the chat so that you don't have to type it on the screen here. But we have a form for you to just request read access to this Atlas instance, and then we'll be able to give you permissions to be able to get in there. And so this is going to be a place where every day we're going to be putting phenotype definitions, at least those that were developed in Atlas. Another resource we're going to talk about is at data.ohdsi.org/phenotype February. This is a cohort diagnostics instance where if we're using cohort diagnostics on a given day, we'll push the results out there to allow for evaluations. And for today, we've already got results that we'll talk about there. Also, the code for where the cohort diagnostics is going to run is out there on our OHDSI Studies Git repository at Phenotype February. So if you are interested as a data holder in downloading cohort diagnostics and running the definitions, we'll be able to go there and grab the code and execute it. And as Gautam mentioned earlier today, our OHDSI Phenotype Development and Evaluation Workgroup is holding office hours on Friday this week, February 4th, from 10 a.m. Eastern time to 12 p.m. Eastern time. That's just a great time to just get together and talk about the process, in addition to all the regular workgroup meetings. So my hope is that all of you will be interested and engaged in thinking about phenotyping, developing phenotypes, evaluating phenotypes, and joining this conversation to recognize and appreciate why phenotypes are so important to all the work we are doing as a community. So, for those of you who have not yet completed your voting, here's another opportunity to do so. And I'm going to pull up the live results to see where we're actually at. Let's see if I drag this over. I'm going to put it in present mode. I'm going to take a look to see what you guys are thinking is important for Phenotype February. Hopefully this will pop up. You guys can all vote at pollev.com/PatrickRyan800. And hopefully it will appear. The white screen is less exciting. I'm going to exit out of that to see if I can maybe show it in the smaller screen. No, I don't know what's happening there, but I can at least see it here. I'm seeing some votes pop up here. So we got at the top of our list, phenotypes we'd like to develop and evaluate together. We've got over 20 votes for Alzheimer's disease, type 2 diabetes, excitement around pulmonary embolism, suicidal thoughts or behavior, heart failure, non-small cell lung cancer, deep vein thrombosis, type 1 diabetes, hemorrhagic stroke, kidney stones, epilepsy, migraines, Parkinsonism, Guillain-Barré syndrome, autistic disorder, depression. I don't know why these are not currently, I guess it's slow to rank them all in priority order on my screen. But I want to encourage you all to continue to vote for this next 10 minutes, because certainly we want to use your input as a way for us to think about as a community how to prioritize what we're going to be doing during Phenotype February. It's gratifying that at least
voting. Patrick, you may have turned the voting off when you did that.
Sorry.
Because, yeah.
Let's see. It should now be, you should all be able to vote more now.
It's back up.
Back up? Okay, cool. Thank you. Thank you, Craig. Okay, so yeah, continue to vote. I want to hear what we want to focus on, and this will be a list that, assuming I can have the technical competence to extract it back out of this poll everywhere, I'll post this so that everybody can kind of see what the community is thinking is an important areas for us to focus. For any of you who are thinking about maybe raising their hand to lead a phenotype yourself. It's gratifying to see lots of people are indeed interested in type 2 diabetes. Hopefully that means you'll all join Mark and the team in the Legend type 2 diabetes work that we're doing. What I want to do in 9 minutes is give you a sneak preview of what you're going to see in the discussion thread that's going to be posted out on the forums.odyssey.org as it relates to what we've done, what we've learned about type 2 diabetes. So a phenotype needs to start with a shared understanding of a clinical description. Here I'm just actually extracting out from the American Diabetes Association from their 2021 guidelines of standards in medical care and diabetes. They talk about the classification and diagnosis of diabetes. Importantly, they talk about diabetes as the overall entity, and then they classify it into general categories, which is inclusive of type 1 diabetes, type 2 diabetes, specific types of diabetes due to other causes, which is sometimes commonly referred to as secondary diabetes, as well as gestational diabetes mellitus. And as you read this document further, they even provide very specific grounded criteria for the diagnosis of diabetes, which specifically can be observable through laboratory measurements, whether that be a fasting glucose, or a hemoglobin A1C value. And these are the types of clinical elements one may want to wish to look at when determining whether a patient is appropriately diagnosed with diabetes. And so I think, at least as it relates to this phenotype, while there's clearly an evolving science about what it actually means to be diabetic, and whether or not, an artificial classification of 1 versus 2 is really so clean cut, in general, I think people have a somewhat common understanding of the clinical idea of type 2 diabetes as it relates to what we might want to look at. The question is, how do we go into our data to identify the people who would qualify for our clinical concept of type 2 diabetes? And so in this first post, what I will discuss is the opportunities for creating cohort definitions using Atlas. And I'll specifically highlight the definitions that we've created to illustrate this point. And I will also be talking about the opportunities to evaluate those definitions using cohort diagnostics. And I'll be highlighting some of the insights that we have to work this point. So let me drag a different screen over here. All right. So let me just drag this over. I got 7 minutes left, which will be fine. So just to illustrate these ideas, in our Atlas phenotype.odyssey.org Atlas instance, we have created 3 cohort definitions for the idea of type 2 diabetes. The first is the more canonical definition that we see used in many different papers, which is just find people with new type 2 diabetes at the time of the first diagnosis. And if I click on that, I can see the most basic rudimentary definition, which would be people enter the cohort when they have a condition occurrence of a type 2 diabetes code that's in the type 2 diabetes concept set. And we want this to be newly diagnosed individuals, so we then require those people to have been in the database for at least a year prior to their earliest event. The concept set of type 2 diabetes is represented by the following concept set expression. Importantly, as an insight here, it is not so easy to just pick one concept called type 2 diabetes, because it actually turns out that there's quite a lot of type 2 diabetes information that's captured on the more general terms of diabetes mellitus. There's also terms that don't roll up to diabetes mellitus at all, such as complications due to diabetes mellitus. And so those actually are additional concepts that are representing different clinical ideas. But if we're trying to find someone with diabetes, then a person with a complication due to diabetes probably has diabetes. And so you generally may want to be inclusive of those clinical ideas. There are also clinical ideas like diabetic under poor control, which is not in the same SNOMED hierarchy as either diabetes or complication, but is something relevant to identify cases. What we don't want in our type 2 diabetes concept set are ideas like type 1 diabetes or secondary diabetes, which as ADA specified are kind of different classifications within the broader diabetes framework. And so this is just a very simple cohort definition that one could use. And in fact, we see this all the time. In any paper you've read of type 2 diabetes, they say, we found people with type 2 diabetes as those that had ICD-9 250 star or ICD-10, E50 star, or I forget my numbers off the top of my head, but E11 star, I think it is like the kind of thing you would see in a paper. But we need to be a little bit more careful and nuanced in thinking about this. For example, one may consider, as we have done in the Legend type 2 diabetes work that Mark has been leading, that we don't just want to specify that you must have a condition occurrence of type 2 diabetes, but we may want to specify additional inclusion criteria to say you must not have type 1 diabetes and you must not have secondary diabetes. So a choice we've made within the Legend type 2 diabetes protocol is to specify when we're trying to find people who are truly type 2 diabetic patients, we want to remove those that have type 1 or secondary diabetes, because that may be potentially a specificity problem for that original type 2 definition that we had. And so this could be a reasonable definition. And in fact, this is borrowed straight from the Legend team's work in terms of the general logic that is being applied there. But one can consider, what is the index date for diabetes here? Here I'm just basing it on a diagnosis. And one may consider that there are other types of observations that one could see in a definition to find diabetes. For example, one might not just look for a diagnosis, but one might consider that the observation of a drug used for diabetes, such as metformin or an SGLT2 or a GLP-1 or a DPP-4, may be an indicator of diabetes. Or the fact that the ADA definition itself says if you have an observed hemoglobin A1C of greater than 6.5%, then you are classified as having diabetes. And so one could consider shifting the index date to making sure that we find that time when someone is truly new to the disease state by changing our definition. Now, these are just definitions. The part that I'll also talk about in our initial conversation for type 2 diabetes is how we can evaluate those definitions. And at data.odyssey.org/Phenotype February, you are going to see that those 3 definitions have been evaluated across 6 databases so that we can examine and compare for those 3 definitions that we have. We've got 3 definitions. We can see how many people and how many records are going to be identified across this network of databases. And what we'll use cohort diagnostics to do is to understand the consequences of these 3 alternative definitions using population level characterization tools such as an incidence rate characterization, such as an index event breakdown, such as temporal characterization to understand sensitivity, specificity, and index date misclassification errors. And so what I'll be highlighting on our initial post is how the Cohort Diagnostics tool could be a really useful resource as you are thinking about investigating whether or not any of these definitions make sense within any of these databases, or maybe potentially even within your own definition. And so we can see here, just as like a very simple insight, we can see that definition kind of 1 through 3. 1 is that broad one of just a code, and that narrow one there is starting you at the first time you have a diagnosis, a treatment, or a lab. And you can see across all of these databases, there's a drop in the number of people. Why? Because we are cleaning up this notion of incident diabetes by finding the people that were truly prevalent. They were just prevalent on the basis of their treatment or their laboratory value. And so we would have misclassified them as incident had we only used the diagnosis code. So it's just the one type of an insight that I learned from this process that we want to be able to, that I want to share as part of this, this Phenotype February activity. But what I hope you all will do is join in the fun in looking at those definitions, looking at the results, sharing any insights or ahas you see in the data, providing your own commentaries about what you want to do, and hopefully more specifically is implementing new solutions that we can consider across our community. So with that, I'm going to stop. I see that there's at least one hand raised, and I'm happy to answer questions. And while we do that, I'm just going to pull back over our survey so that we can see, as people are interested in different diseases, what our top targets of our Phenotype February may be. Harold.
Did you have a question?
Yep, I think I hear you now, Harold. Go ahead.
No, I think I raised my hand by mistake.
Oh, okay. Very good.
I know it's 12 o'clock, so if people have to leave, that's fine. I'm going to leave the recording going. So Patrick, if you have some time to answer some questions, just let's raise hand and we'll go for as long as we can. So Evan.
All right, so that's the introduction of Phenotype Library, Phenotype February from Patrick. So with that, as you can see, so this is the introduction. Feel free to kind of watch it through OHDSI website. And one other thing I want to show really quick is, as you can see here, we have the updates, and then for each day, as you can see, now that we're on the 10th, I guess for the Western part, it's still February the 9th, we have 8 phenotypes already out there that are for discussion. So let's see, for the example that Patrick showed us earlier, so we can see for type 2 diabetes. So first, Patrick kind of posted the draft or kind of the version of the phenotype for type 2 diabetes from kind of his understanding or the data he has tested from his side. So here are kind of all of the conversations sits here under OHDSI forum and then the general board. So that's kind of, as you can see, it started on February the 2nd, and then we do have kind of people's conversation and discussion up till I think this one was really from 3 days ago, which really it's kind of been discussions for the last week or so, and that will be kind of the theme for all of the other phenotypes as well. And then if we go to the OHDSI forum and then general board, so you can see kind of each day we have a topic for like each of the phenotype of interest. So you can see here, type 1 diabetes or Alzheimer's, so different things. As I know that all of you here probably have used some of the disease here for your own research. So definitely join the discussion there and also see kind of what the community have come up with for kind of the standardized or the version that we the community think is the best way to do the phenotyping for the certain disease. Any questions or comments on this part? On the Phenotype February?
I'll let questions go first.
Mm-hmm.
Okay, if you guys don't have any questions, then I'm going to help push this one more time. What we would like, the ask here for the community, and I think this is a great chance for the Asia Pacific community to help out here and actually, you know, participate in something that's actively going, because there's a lot of times, you know, things happen and we don't know about it here in the Asia Pacific community, and it's like after the fact, right? Here, it's really not after the fact. It's going and folks are involved. You don't have to have the data. You don't have to have, you know, a lot of expertise in it. But I suggest, you know, if you guys can go through them, and if it's an area that you are passionate about, or you have someone that you know that might be, you know, an expert in that area, or at least probably more than I know about any of these disease areas, it would be great if you guys can go look at them, look at the discussions, and if there's some feedback you guys can provide, that would be really wonderful, and great to see. So I think I see some activities. Oh, that's you posting. So you can see there's the forum. If you want access to Atlas, there was a link there that you can get to get to the actual Atlas version of this, of where all these cohorts are. You'll have to replay the video. It's out in the forum. It's not on here. But you can register, and you will actually get access to it. And you can see all the phenotypes. And of course, after this, those are all going to be public anyway. So anybody can actually access it if you want. So again, please, the call here is for the community to help out with providing better definition of these particular phenotypes. So it seems right here, Jing pulled up where you can go sign up for it. But this is the phenotype library that OHDSI is developing. So one last chance. Any questions? All righty, Jing. Last topic.
So next, I will share. I'll share the deck again. One second. All right. So can everyone see the deck? Cool. So last but not the least, we want to first give a quick overview of our next community call, which is 2 weeks from today. And as you all remember and enjoyed in late January, the last community call, we had Claire coming over and kind of really give us a very informational CDM workshop, and also thank you for all of your questions. So I think we were able to address about like 10 of your questions from the registration. And for the next community call, we would like to continue the conversation, which will kind of finish up all of the remaining questions from your registration, and then we will open up to the live audience to have a Q&A session as well. So if you have any questions or any suggestions to the CDM and or a question you want to ask Claire, so please join us for the next community call. Cool.
Awesome. So, thank you.
All right, so that is all we have for today. Any other questions before we close the call? All right, cool. Then thank you so much for your time and attending the community call today, and we'll see you next time.
Bye, everybody.
Everyone.
Bye. Bye. See you next week.
Thank you.
Thank you.